Yo, welcome back to the channel. So today I am going to be putting together a video covering my own frame, the HaloRC Osiris. The Osiris released back in January last year, and I released a build guide at the time, but it was really quite basic and not filmed very well. I think I've got a bit better at filming these videos since then. Since the release, quite a few different things have changed, component selection, etc. So I really wanted to do an updated video on the Osiris. So we're going to do the actual build of the quad itself, and then we're going to go out and fly it, tune it, and get it flying as good as I can possibly get it to fly. And yeah, you're going to join me along the way. Before I head over to the bench, just want to point out that this isn't going to be a totally fresh build. I really liked the components that I used on the JB build, especially those Pacer V2 motors. They're so smooth. I really wanted to use those again, but unfortunately I can't seem to find them for sale anywhere. The place that I got them from originally only had 2 left in stock, so I couldn't buy another set of those. So I was kind of left with, do I dismantle the JB frame and use all those parts to build up a new one, or do I try different motors? The Pacer V2 does come in a 2306 version. So I figured, okay, I'll just get the 2306 version and build up a fresh Osiris using those. So these are the 2306 Pacer V2s. And yeah, same design as the last ones. Really nice, simple design. I like this color as well, it's kind of cool. But unfortunately, on first look, they don't feel quite as smooth. They've got a tiny bit of a notch. Now, they're quite a bit smoother than some motors that are very notchy, but they're nowhere near as smooth as those nice 2207s that I put on the JB build. So, yeah, I'm left with having no choice, but I mean, I really want to I want to compare the Osiris to the QAV-S. So, and all my testing on the QAV-S has been done with all that entire setup. So I'm just going to reframe it. The JB build is going to be coming apart, and I'm going to be moving all of these components, especially these really nice super smooth motors, over onto an Osiris. Now, there's a couple of things about this frame that I don't like. I personally feel that the props are way too close to the frame. Not such a big deal at the front. If you're running a Hero 9, it's very hard to get the props out so far that it clears the Hero 9. So most people are used to running, you know, I'm used to running props underneath the Hero 9, but the further away and the least minimizing the amount of prop that runs underneath the GoPro is probably quite important. It's more of an issue at the back of the quad. If I grab a LiPo here, so you can see here, got the LiPo there, and the props run so close to, we're talking 3 millimeters, probably 3 millimeters away from the battery strap. It's quite hard to show on camera. But yeah, the gap there is just, yeah, this gap between the prop and the strap is so small that as soon as this battery shifts to one side or the other, if you crash or something, then the props just cut the straps all the time. And I really don't understand why you wouldn't make the arm just slightly longer to stop that from happening. The other thing that I thought was an issue at the start is that these props, look at how close they've got them. There's only about a 2 or 3 millimeter gap there between those. So I thought it would be an issue, but the black box doesn't lie, and didn't seem to really cause a problem. So at least maybe I've learned something there, that maybe I could get my props a bit closer together in my own designs, but overall I prefer to have them further spaced apart. Maybe it makes my frames feel a little bit more stable, like they want to fly flat. This is maybe a little bit more twitchy because the props are in closer together. It's going to be very, very minor, and the reality is that the flight controller is going to compensate for that, because it doesn't matter if those props are really close together and that causes this frame to rotate faster at a given thrust of the motors, then the flight controller will just counteract that by using less thrust and just reaching your set point. The motors being further apart, if maybe it needs more thrust to achieve that set point, then it will just use more thrust to achieve that set point. It's interesting when you try to break it down and compare these tiny little differences, but I mean, they definitely make a difference. I try not to compare these too much to cars, especially Formula One cars, but it is something that I'm into. But Formula One cars, you make a difference of a few millimeters and they say it can affect downforce and top speed and all sorts of things. That's a few millimeters on a massive Formula One car. So probably fractions of a millimeter can affect how this thing actually flies. But because it's being driven by a flight controller, maybe a lot of those characteristics are actually cancelled out in a way. So yeah, it's going to be quite interesting to see how this flies when compared to an Osiris. So yeah, do a bit of a montage of me taking this apart and preparing all the parts ready to do a new build with them. Then we will be cracking open a nice fresh Osiris and putting that together, and then yeah, so let's just get on with it already. Laters.
Talk about quiet with a big mouth. Listen for the doubt, then call it. Make you out for what you say to me. Look at every single date. If you got what I need, then oh, I'll take you on like a big deal. Legs you can unfeel, key in ignition. Just keep me full like I had a meal once in a while. Feel all that I know you like it, can't fight it. I'ma let you ride the wave. I'm New York and you're LA. Come together, feel the shock waves.
Okay, before we get started on putting the frame together, I just wanted to go over the various options that you have when ordering an Osiris frame. Other than choosing what prop size you want to run, whether it be 5" or 6", then it comes down to what additional TPU parts you need to work with the components that you've chosen. So, camera mounting. 3 different camera mounts. You've got the micro, mini and DJI. So obviously the DJI one is for DJI. That's for the original metal official DJI camera. So if you're running the DJI camera, obviously you're going to need that. If you're running the Nebula Pro or the Nebula Nano, well, Nebula Nano might work with this, but don't run a Nebula Nano. If you're running Nebula Pro, then that's a micro camera. The new Cadix camera that's due out soon, that's also a micro size. So you're going to be wanting to choose the micro camera mount. That is also used for analog. So if you're running an analog micro sized camera, you're going to choose that. And if you're running a analog mini size camera, you're going to choose the Osiris mini camera mount. The next part that you're going to need to choose is your antenna mounting. So if you're running analog, you're going to use this SMA mount. This has a slot for the Unify or just for a standard non-Unify style SMA mount. Antenna goes, SMA mount in there, antenna out there. This extra piece of TPU there stops the antenna, the copper or the brass of the antenna touching the carbon, just in case you've got a short and power running through your frame for some reason. It's not going to affect your video, so that's the idea with that. The Osiris, when running DJI, air unit is a no. Do not run the Osiris with an air unit. The only VTX that you can use when running DJI at the moment is a Vista. And if you're running a Vista, running an SMA out the back is going to be quite tricky as well. Personally, I only recommend using the Vista antenna mount, this one, and your Vista antenna obviously sits in there and it's all nicely away from the VTX section in the back of the frame. So if you're running DJI, you're going to go with a Vista and the Vista antenna, and you're going to be using the micro camera mount or the DJI camera mount. For me today, I'm going to be using Nebula Pro, so I'm going to be going with the micro camera mount and the Vista mount. So I'll get rid of these. Yeah, unlike a lot of frame companies out there, I offer full range of TPU. All this TPU is all available on the website to download for free and print yourself, or I have it available in 7 different colors that you can order direct from me. I have HD camera mounts for the Hero Session, the Hero 7, the Hero 8 and the Hero 9, and they're all available in either 20 or 30 degree angles. The 7 and the 9 both come with one of these detachable lens protectors. So yeah, so I'll be going with a Hero 9, and I like to go fast, so I'll be running 30 degrees. Okay, so when you get your Osiris, it's going to come like this. Get all the carbon fiber required, pack of hardware and a couple of straps. And nice little thank you card. So got top plate, bottom plate. These are the middle plates. Got a little front brace of the arms, obviously, and your hardware pack. And this part in particular is the Osiris's piece de resistance. So yeah, this is what I call the spine, and it's what sets this frame apart from any other basically. This spine is a 5mm thick piece of carbon, just like the arms, and is used to strengthen up the center of the body of the frame. Traditionally, frames all have the arms going from the motors to the center point of the frame. Now, that's actually the longest distance from the motor to the body of the frame. So it makes the arms longer. The arms are the thickest part of the frame, so that also makes it heavy. That's the heaviest way to design the arms. By moving the arms away from the center of the frame, what you end up doing is making them shorter. So you can see here a 5-inch prop would only just like go to the center, but by moving them further away like this, the 5-inch props are pushed out and to the side, and the arms are still kept relatively short. But then you have this gap in the middle that you have to bridge. A couple of different people have done it in different ways. You can have a really thick bottom plate, a really thick middle plate, and add the strength back that way. I think Pyrodrone, they developed some fancy aluminium piece to make that work for them. Me, I came up with this spine, and that sits right in between these two arms here and provides an extra point of contact for each arm to butt up against. So when you take an impact here, instead of it just being two arms there like fighting each other on this contact point, it's actually going to push into that and into that. So it has multiple points of contact to deflect the impact forces. Because this this spine is 5mm thick, it also means that the rigidity going across the flight controller is really, really high, and that helps with vibrations and frame resonance. Because this section is so stiff, what I was able to do is actually split the middle plate into two sections. So you have the rear section like that, the front section like that, and you're actually so all the vibrations from the front and are only going into this side of the flight controller. All the vibrations from this side of the frame is only going into this side of the flight controller, rather than all the vibrations going into the flight controller all at the same time. I feel that this has reduced the amount of frame resonance that is picked up by the flight controller. Maybe not, the frame resonance may still be there, but because of this design, it's able to, well, I guess decouple the points of vibration. It's kind of bro science. I mean, I don't know. I didn't expect it to. I just came up with the idea, tested it, and it worked really well, so I ran with it. The bottom plate actually forms the front section of the frame, and then the top plate spans the entire frame. So the top plate, you see, it's got these 3 sets of cutouts. That's for your lipo to go through. So if you're running a HD camera on the front here, it's going to be at an angle, so it goes back slightly, and you can sit your lipo on the back here and use the slots there and there. If you're not running a HD camera, then you can sit your battery right in the middle, get the center of gravity really nice, and run the strap through there and through there. By running the straps through the frame, so you go up through there and down through there, it just holds the strap in place. So when you take your battery off, you haven't got to constantly adjust where the buckle is. The buckle will just always sit exactly where you set it. The strap doesn't move from side to side, and it doesn't drop underneath. So I just feel, and by doing them like the weave of the carbon fiber is going like this and like this. So the strongest shape that you can cut out of a piece of carbon fiber is a rectangle, not a triangle. If it was solid metal or something, then triangles would be stronger. But to match the weave, I feel that rectangular shapes, or at least shapes that are moving in the same direction as the weave, is by far the strongest way to cut carbon fiber. If I was to cut triangles here and here, the only pieces of carbon that have the fibres going all the way through the frame would be on the outside, because all these triangles would just divide up the remaining central threads. So I've got this nice strong central piece down the middle where the threads will run all the way through there, and I have 3 of them and an extra bit in the middle there. I don't remember ever breaking a top plate. This is only 2mm thick, no need to go any thicker than that. Works straight. You've got a little cut out hair, which is actually a blood drip, if anybody didn't realise. That's for running your Immortal T or antennas off the back of your GoPro mount. So all the GoPro mounts come with one of these Immortal T mounts in the back of them, which is for the best way I feel for mounting your Immortal T antenna. So you just run it up through the cutout and into there. That's the only thing that I recommend putting from the inside of your quad through the top plate. Otherwise it just gets really awkward whenever you want to work on your frame. You don't want a LiPo lead coming through there. Absolutely no need to have your LiPo lead attached to the frame at all. You want your LiPo lead to come off your 4-in-1 ESC and into the battery without causing any interference with the frame at all. So we'll get into that later when we do the build. One of the most important things to account for when having a frame cut is the tolerances. So every CNC manufacturer will have different degrees of tolerance. All the carbon that I use all comes from Armatan. I've tested quite a few different places over the years, but I just find Armatan is just the best in terms of quality of finish, strength and precision. The tolerances are really, really good. However, it's one of my bugbears when it comes to other frames, is that when you get them and all the bolts just drop, they just drop straight through the holes really easily. I mean, that is the #1 cause of slop in the arms and any play in the frame once you've put it together. If that bolt can move within the hole, then the only way the thing is going to stay rigid and have no play at all is if you clamp it right down really, really tight. So I've gone down the route of making my holes very, very, very tight to the bolts that I use. So sometimes when you get an arm, for example, you may find that the bolt, you're like, oh, what the hell? The bolt doesn't even fit. That is because I've had to make a choice between, because Armatan, they're not perfect. I don't think any of them would be perfect. A fraction of a millimetre too small and this bolt isn't going to fit through, and a fraction of a millimetre too big and it's going to be a bit of slop in the arm. So I've had to pick a hole size that I know that when Armatan cut them and the holes are maybe a little bit too big, then that's not going to be there's not going to be any slop in the arm at all. But occasionally they cut the holes a fraction too small and you just can't get the bolt through. So don't force it. Take a small file like this, maybe a rounded one. I prefer these triangular shaped ones because they remove a bit more material quickly. Or even use a drill with a 3mm drill bit and just remove a tiny amount of material. Take your bolt, test it, drill it again or file it again, maybe try it going in from both sides, and just widen it enough and remove a tiny amount of material from that hole, just enough so that your bolt just drops through and is, you know, you don't want to have to screw this through, but you don't want to be able to go like that and it just fall through. You do want to be able to have to push it through, but not screw it through. So take from that what you will. If you think that's bad on my part, then so be it. I've been doing this for 5 years. I've tried it the other way, where you make the holes where you're never going to need to file the hole out, and what you end up with is some holes the bolts just drop through and other holes are perfect. So I've tried, and every manufacturer I've gone to have been exactly the same. So you get tiny little differences between the hardware as well. So it's not even just relying on the carbon to be perfectly cut. And when I say a fraction, I'm talking about 0.05, like 5/100ths of a millimeter, not even just a tenth of a millimeter. Tolerance is usually, you know, 0.1 of a millimeter is what most CNC manufacturers aim for. But yeah, to make this fit perfectly, you could go half of that and it could mess it up. So, okay, so let's put this together. Bloods from the future here. You need to fit your stack bolts before putting the whole frame together, because you don't have access. You won't be able to get bolts through the middle plate when it's all together. You need to fit that first. I like to start with the bottom plate, and I'm going to go ahead and fit the spine to it. So you take your 2 shorter socket head bolts like so, put them through there, and then take your spine and fit it like so. Then you can take your middle plate there, and just hold that in place with a bolt, and then take the front plate there, the front middle plate there, and hold it in place with the other bolt. That just puts everything roughly in place to fit the rest of the parts. So top plate last. So the way the arms go is that you'll see that there's a little semicircle half hole there. They go together to make a hole like that, and then you can see there's that triangular gap that obviously goes into the spine. So that's the easiest way to remember that. So you literally just take an arm, butt it up against the spine. You'll feel that it will line up nicely, and the hole there. Then you take one of your longer bolts, and you will need to screw it a little bit just to make sure that just helps get them all in line. There you go. So make sure there isn't too much resistance when you're screwing that bit through. Just want it to help, just screwing it to guide it rather than to actually force it through. So again, take it with your semicircle facing into the arm. Whack it in there, and it will butt up against the other arm and the spine and perfectly align with those holes. Then you take another long bolt and get that to feed through the 3 plates. Then you take another shorter socket bolt that goes in between the 2 arms and into the second press nut of the middle plate. Like so. Then you take 2 20mm standoffs, attach them there and there. And then just repeat on the other side. You could do it from the bottom or from the top, it doesn't really matter. Don't worry about doing these up all really tight to start with, and button all that down at the end. So there's the arms all attached. You just fit these 2 standoffs. One thing you will notice is that the holes that are there for your stack bolts are blocked by the bottom plate. So yeah, I have made a bit of a mistake here, and if I'd have read my own instructions I would have known to do this from the start. But you're going to want to fit stack bolts before putting the frame together. It should be the first thing you do with these middle plates is fit 4 bolts and hold them in place with some nuts. 20mm deck, 18mm standoffs are perfect. That's what I personally use. So run 4 18mm bolts through there and put nuts on them. That's just going to hold them in place. You can get a driver to 20x20, but you can't get a driver to the 30x30. You're just going to have to do it like this, go in from the side and hold it, and then do the nut up like this. It's not difficult. Once these nuts are done up and your stack bolts are all in place, your stack never comes loose. You're never going to need to tighten it up or anything like that. I've never really had a problem where I've had to take the whole frame apart to get to the stack. Yeah, once those stack bolts are in place, then it doesn't really matter. So this little front brace plate is this little front brace plate here is used to go at the front, obviously, and it raises up the front standoffs so that the whole top plate is in line. So use these longer 8mm M3x8 bolts. You can see I shouldn't really be screwing this into here. So yeah, although I'm using a driver again, I'm not having to use much force. This is perfect tolerance if you ask me. Just using a driver to get it to go through, but not having to use the bolt to widen the hole at the same time. So that little brace plate just goes on the front like so. Then attach the 2 longer standoffs that come in the kit to the front. And then use 2 of the 6mm bolts at the back and use the final 2 20mm standoffs like so, and then finally the top plate will go on like that, and you use the final remaining bolts to secure that in place. While this is together, you can see that obviously there is a huge amount of room to build your stack, so plenty of room to route your LiPo lead. You can either have it coming out the back like so, or out the side. The rear area is reasonably small. There's plenty of room there for any analog VTX, and there's enough room there to run a Vista, but obviously a big fat air unit is not going to fit there, so do not use an air unit. Got 20x20 mounting, which is M3, which isn't ideal for mounting the Vista, but it works just fine. Let's be honest, you can run an M2 bolt through there and a nut and it will hold it just fine. A little bit of double-sided foam to secure it in place. Up the front you've got plenty of room for your camera, and you'll be able to fit a receiver there as well. So yeah, pretty simple frame to put together that has a lot of room and only weighs 90 grams. So yeah, lots of room to work with, and very lightweight and very strong because of the way it's designed. That's the frame put together. Next up we'll be moving on to building it up. Okay, so now that the frame is together, including the stack bolts, yeah, I mean I design the thing and even I do that, so don't feel bad if you put the frame together and then realise, I need to get the stack bolts in. You've got to take it apart and put it in. It's not really that big of a deal. Just, yeah, do it. Yeah, so now the frame is all together. I'm going to put that to one side. Like my last build guide, the way I like to build is to do as much prep work off of the frame as I can. So starting with my motors. Now obviously this is going to be a bit easier for me because I'm taking these parts off of another quad that was already built. So I start by soldering LED race wire to my 4 motors. So those are already done for me. I prepare my Vista by soldering on the power and MSP connectors, ready to plug that into my flight controller. Speaking of the flight controller, I solder my receiver to the flight controller, ready to go. And then my ESC I prepare by soldering on a capacitor, my LiPo lead, and I also like to solder on motor wires. The way I like to do it is I have all my motors prepared like that, then I solder on motor wires onto here and then fit everything to the frame, and the last thing I do is solder the wires coming from the ESC. I just trim and solder to the LED race wire. I find that's the easiest way to make the wires just the right length and to do a really nice clean build. So this one hasn't got any motor wires on it yet, so I'm going to solder those onto it. Okay, so let's start by fitting the motors. Okay, now that the motors are in place, the next thing I like to do is fit my Vista. I like to run the cable from the Vista to the Nebula Pro camera right along underneath everything. These nuts raise the ESC up quite nicely, so enough that the cable can run nicely underneath and not get damaged. It's nicely protected, keeps it all out of the way, and makes for a nice clean build. So I've prepared my Vista with some of this double-sided tape, and then I've got 2 M2 by 16 screws, bolts, and 2 nuts. So I'm going to go just use 2 bolts with the double-sided tape will be enough. So remove the backing tape and then just make sure you got it the right way around, and use these bolts to just line it up perfectly. And push it down. And that tape's going to be enough to hold it in place mainly. I just like to use these, I just like to put a nut and a bolt through just for an extra bit of security really. The easiest way to do that is to get the nut started. Just hold it with your finger on the other side and do it up until it pinches. Got to remember they're plastic, so you can't tighten them up very tight. But it's just enough to take a little bit of the strain off of the tape, and it helps push it down into the tape as well to keep it stuck. So they kind of work together. Here we go. So you can see now that's really nice and secure in there. As I say, well, you can see the cable just wants to go that way. So I run the cable like this, nice and cleanly, down to the other end, and then use this micro mount with the bolt through already. There we go, there's the camera in place. Obviously I can adjust the angle, so that's at a nice 30 degrees or so. Align all these nicely, and then tighten her up. I've got to tighten that down. Like so. Pull this back there and keep that out of the way. Next up, fit the ESC. So I like to actually run my ESC cable up here, like so, and into the flight controller. Seems to work nice and seems to be a nice clean way of doing it. Works well for me. The Acon comes with some nice little plastic things, but I'm just going to use TPU. Like that. Before putting the flight controller in place, just going to go around each motor. Set the wires where I want them to go, and then trim and solder each one to the race wire. So as I said earlier, I just feel that this is the easiest way to do it nice and cleanly, because you've got all this slack. You can move the wires exactly where you want them and line them up ready, and then just trim them off to the perfect length.
Look at people and I wonder all day, who are you and you are not the one in your way. And then I think about myself and I state, I'm a pretty boss, look almost your brain waste. I'm a freak in the sheets, but I got class. I'ma grab an ass if you want it. Best you ever had, give it to you back. Ooh. Talk about quiet with a big mouth. Listen for the doubt, then call it. Make you out for what you say to me. Look at every single deed. If you got what I need, then oh, I'll take you on like a big deal. Legs you can unseal, key in ignition. Just keep me full like I had a meal once in a while. Feel all that I know you like it, can't fight it. I'ma let you ride the wave. I'm New York and you're LA. Come together, feel the shock waves.
Okay, so motors are all attached to the ESCs now. Vista is installed. Everything, because we did all our prep work earlier on, everything's ready to just plug in now. So next thing to do will be to route my Vista, is to route the Vista cables to the flight controller, and yeah, just plug it all in. Nice and easy. Let's just plug it in. Find it's easiest just to start with the ESC cable. Then plug in your Vista cable, which is going to run underneath like so. And as neatly as you can, run that under there out towards the front. As for the capacitor, a couple of different ways you can run the capacitor. I usually just zip tie it to the rail, or the bottom plate rail. I'll often zip tie it there. These cables aren't quite long enough, but could also run it right in there, so there's plenty of room once you tuck those wires away. You could also run it up here in the same sort of way. Quite like the idea of running it there, so gonna make some sort of TPU mount to hold that in place. So yeah, just tuck those wires away neatly, and you see there's a nice bit of clearance from the capacitor to the flight controller there, so it's not going to be touching it or anything, and it's even going to hold my tracer RX in place. So next up we're going to be taping up, I like to tape over the solder joints just so that if any water or grass gets on them it doesn't short out. Then I'll attach zip ties to run these antennas off. Then I'll attach the Vista antenna like so. And then the top plate just slots inside there like that. I can see that capacitor is a little bit high. I'm going to push that down. There we go. So yeah, nice clean build. Plenty of clearance in there. Now I'll be attaching the GoPro mount on top. So yeah, that is basically it. Next time you see it, it's all going to be finished up, and I'm going to be in the field doing my maiden. Laters.